Hello everyone, welcome back to my channel, your go-to destination for unraveling the mysteries of cutting-edge technologies on Google Cloud. I am Mustafa, and today we'll continue our journey into the heart of Google's Bigtable. Bigtable stands as Google's fully managed scalable NoSQL database service, tailor-made for efficiently storing substantial data in a key value format. It is the go-to solution for diverse applications like personalization, ad tech, financial tech, digital media, and the Internet of Things. Bigtable takes the lead in supporting robust read and write operation, ensuring low latency access for swift processing and analytics of extensive datasets. Monitoring and managing the health and performance of your Bigtable instance are made seamless through a range of options. These options include informative charts detailing storage, disks, and compute utilization, flexible choices for autoscaling nodes, data replication to enhance durability and availability, and comprehensive backup and restoration features for tables. In this hands-on lab, you will dive into the world of Bigtable management. You will explore various charts, gaining insight into disk and CPU usage within a Bigtable instance. Additionally, you would learn to optimize your existing cluster by implementing node autoscaling, ensuring your resources align with actual needs. The lab also guides you through setting up replication for added data durability and demonstrates the essential step for effective backup and restoration of data within Bigtable. So, whether you are a seasoned data enthusiast or just stepping into the realm of database management, this lab provides a practical and insightful journey into maximizing the capabilities of Google Bigtable. Let's roll up our sleeves and explore the power of Bigtable together. So to get started, we'll click on Start Our Lab. After starting our lab, we'll open our lab in an incognito window. Then we'll grab our password along with us. So click on Next. We're pasting our password here. And we'll click I understand here. Just getting signed up into our dashboard on our Google Cloud Console. And we should also agree to the terms and service here. So let's agree to the terms and service. Okay, continue. So we are good to go, and this is our home page for now. So let's explore what we are going to do for this lab. So going over the lab objectives. Our objectives for this lab, first is to monitor disks and CPU usage for a Bigtable instance. The second objective is to configure node autoscaling and replication in Bigtable. And our final objective is to backup and restore data in Bigtable. There are some prerequisites for this lab, like designing and querying Bigtable schemas. So it's also one of the videos in this playlist, and streaming data to Bigtable. And that's also one of the videos in this playlist. So the setup and requirements, we are good to go. Make sure you open your lab in an incognito window like I showed previously. So let's activate our Cloud Shell. So click on this to activate our Cloud Shell. Here is our Cloud Shell homepage. It's getting provision for us along the line. So we'll click on continue. So you can see we are provisioning our Cloud Shell machine, and after that we'll connect to our Cloud Shell instance. Then let's paste the code we copied, which is gcloud.list, to list the active account on this project. So this is our active account. And to also see our active project, we can do gcloud config list project. So we'll also see our active project account for this lab. So that's regarding that. So let's keep exploring the instruction. And that's a little bit on the setup and requirement. And the final check that we'll see here is to see if we have the required IAM admin setup for our compute engine default service account. So we will just navigate to IAM under IAM. So here we are, and this is the service account ID that we have, and it has the expected permission, which is editor. So I think we are good to go. So it wants us to have an editor account. So if it does not have an editor, that's when you just attempt to change it by using this pencil icon. So but we are good. So for task 1, we want to use data flow to create high throughput read. So don't forget that the main intention of this lab is to monitor and manage Bigtable health and performance. But before we can do that, we have to first simulate actions on our Bigtable instance so that we can now monitor how it is going. The first thing we want to do is we want to enable data flow API. So this code that we are copying, it's the command line instruction for enabling the Google Data Flow API using the Gcloud command line tool. And a little bit of the breakdown. So this Gcloud is just the normal Google Cloud Platform command that we use to interact with Google Cloud resources, configure settings, and perform various tasks. So if you are quite familiar with the CLI, you'd know of this Gcloud command. And then the next one, which is services. So this is like a sub command and is used to enable or disable a service in GCP. So the next one we are using is enable. So this flag enable means that we want to enable a particular service. And the service that we want to enable is dataflow.googleapis.com. Dataflow.googleapis.com. So this is the API identifier for Google Cloud Dataflow. By executing this command, you are enabling the Dataflow API, which is a fully managed stream and batch processing service for big data processing and analytics. So that's just a run over of what this command does. So we'll copy this command and paste it in our Cloud Shell. And it should help us enable the Google Cloud Data Flow API in the background. So that's regarding that. And the next thing we want to do is we would now also paste this command. So what this command also does is that this command that we are doing, that we are about to like run now, it just provide a command line instruction for running a Dataflow Flex template on Google Cloud. So here is the breakdown of what we are doing here. So the command line gcloud dataflow flex -templates run. This is just typically the main command to run a Dataflow template on GCP. So it initiates the deployment and execution of a Dataflow job using a flex template. So flex templates are like predefined templates that have been written for us, that we can just look at the template that align with what we are doing at a particular time, and we can choose that template. So there are like multiple amount of templates for batch jobs, for streaming jobs that you can pick from. So the next command, which is serve recommendation workload. So this is a user-defined name that we chose for this particular Dataflow flex template one that we are using. So this name is user-defined. And the template file GCS location. This is the flag that specifies the location of our template in our Google Cloud Storage GCS. So and the part that we are concerned with is this part here. And going to the next command are parameters. So this flag is just used to pass parameters in the Dataflow job, like you all know. And in this case, we are using it multiple times. You can see that we are using parameters. That is because we are passing multiple parameters. And the first one we are passing here is the Bigtable instance ID. So the name we are using here is San Diego. For the parameters, the Bigtable table ID, the one that we are using, the table we are concerned with is current condition, and the workload rate that we are concerned, which specify the workload rate parameter. We are using a parameter of a workload rate of 1 million, and our region for this lab is US East 5. So before we go ahead, I would show you that all these instances, they should have been created for us when we initiated this lab. Our Bigtable instance ID, our Bigtable table ID. So we've explained how to create a table before in the previous videos in this playlist. So we are not going to like show how to create a table here. The table has been created for us. We are just talking to the table. So our navigation menu, under databases, we have our Bigtable here. So when you click on Bigtable, you'd see the cluster that we are concerned about, and you see the table in the cluster that we are also interacting with. So this is the instance ID. The instance ID is San Diego, the one we used. So if I click into this San Diego instance ID, you'd see this is the cluster ID that we have. And when I go to the tables, we should see the tables that we are talking to. Tables that we are talking to in our command is current conditions. So this has been initiated when we created this lab on the go. Yes, so let's run the command. So the explanation that I was doing has made me forget to run the command. So let's run the command. And you see that immediately the commands get run, you'd start seeing the job also populating here. So let me click on refresh, and you can see this. So this job is still getting queued, and as we refresh the state, you see that it's progressing from different states. So we don't need to wait here till we go to the next task. So we can just keep exploring the next task. Then I'll come back to this one, and you would see that the status has improved. So that's regarding that. So delay checking our progress till then. So the next task is to monitor disks and CPU usage, and that's the major concern for this lab. So I'll just talk over the importance of maintaining or monitoring your disks and CPU usage on the Bigtable instance. So there are different reasons for doing that. One of them is performance optimization and troubleshooting. And under that, we can identify bottlenecks. So you can identify bottlenecks of high disks or CPU usage. And they can also indicate performance issues like overloaded clusters, inefficient queries, or unbalanced data distribution. Another sub-function or another sub-reason is underperforming optimization and troubleshooting is to take corrective actions. So when you monitor your disks and CPU usage, you can easily take corrective actions such as add more nodes for capacity, optimize queries, or even rebalance the setting of your data in your Bigtable table instance. So the last one we'll talk about under this subheading is prevents slowdown and errors. So when you are on top of your disks and CPU usage, you can prevent unnecessary slowdown or resource constraints, and you can ensure that you are having optimal performance, and you can avoid errors during read and write. So another part is cost management. When you monitor disks and CPU usage, you can right size your clusters so that you would not overshoot and you would not undershoot. You can also enable auto scaling. So Bigtable supports auto scaling based on CPU and disk usage. Automatically adjust node count to match your workload demands. Another one is optimizing cost. So effectively monitoring enables you to scale resources appropriately and maximize storage efficiently. So when you are on top of your cost management, you can optimize cost, you can right size your cluster, and you can auto scale perfectly. So let's go to capacity planning. So monitoring your disks and CPU usage can help you anticipate growth. So you can track usage trends of your Bigtable table instance and forecast need for improvements on your cluster, or how you can restructure your table columns. And another one is prevent outage. So when you're on top of your disks and CPU usage, it can help prevent the service disruption by ensuring adequate capacity to handle spikes in data or data volumes. So under anomaly detection, you can identify unusual pattern also. Let's say something like a faulty hardware or data corruption or security breaches. So if you just notice that there's a sudden spike in the data that is loading in the instance, and you know that there's nothing warranting this from your hand, so it can help you troubleshoot further, and that may lead to that may be as a result of a faulty hardware or a corrupted data or security breaches. So the next one is early intervention. So it helps you detect issues and helps to have a timely investigation, and it can minimize the impact on operations. So there are a lot of specific thresholds to monitor under your CPU utilization and disk utilization. So we'll discuss about that, and you can see here that Bigtable Google generally recommends that you utilize less than 70% of your disk storage in a cluster for latency sensitive application. And they also recommend that your storage utilization per node remain below 60%, and you can easily add more nodes along the line to your Bigtable instance. So that's an overview of monitoring disks and CPU usage. So we've discussed a whole lot here, and you can rewatch that particular part so have a full grasp of what we are talking about here. So let's see if our data flow job is done, or we should move to the next one. So let's refresh this, and you can see our data flow job is now running. You can decide to click into it if you want to. So I'm just going to explore clicking into it. Yeah, so this is our Bigtable job. This is just the step that we are doing here. So the first step, we are generating the sequence and we are doing the Pado. That means we are reading the data from a particular table. So that's pretty much. There are also sub steps inside them that you can check if you want to go further. And there's a step info that you can explore what are the things that are going on here. And these are the time that it would have taken normally. But because data flow uses parallelization and does it in distributed format, so you can see that the time is actually reduced. The actually time that this thing took to run is less than 5 minutes, and normally it would have taken 2 minutes 21 seconds for the reading part, and it would have taken up to 25 minutes 55 seconds to do the Pado functionality. So that's regarding that. Yes, so let's keep going, and let's go to our navigation menu under database. So let's view some monitoring charts in our database part. From our navigation menu, we'll go back to our database, which is Bigtable. So click into Bigtable, and you can see that it's loading our Bigtable instance for us. So this is the instance we are concerned with. We click into San Diego, and after that we can explore monitoring. Let's explore the monitoring part. So there are some monitoring metrics that comes with our Bigtable instance automatically, and you can see them here. So let's follow the lab so that I don't end up skipping anything. So we've done this part. So the first question that we have here is, which chart display the storage usage as a percentage of the total storage capacity for each clusters? So we are looking at the storage usage as a percentage of the storage capacity for each clusters. So let's go to our charts and look at this one. We are looking at storage usage as a percentage storage capacity for each cluster. So it's not CPU utilization, it's not this part. So we keep going down. It's not all these ones. It can be storage utilization in bytes, but they said as a percentage. This does not have anything related to percentage here. So this looks like the right answer. It has a percentage utilization, and I would go with storage utilization. So I'm just going to pick this and submit, and we are good to go. So for the next one, you can calculate the storage usage per node by dividing the storage utilization in bytes by the number of nodes in the cluster. So that's regarding that. This is just time. So for the next question, for the existing cluster, is the storage utilization per node below the recommended limit of 60%? So let's check the storage utilization per node. Is it below the recommended of 60%? So you can see this is what we are currently. So we are in like this line that we have. We are just a little bit above zero, or just on zero. So it's actually below it. So that's yes. So, and under monitoring CPU usage also, we can also monitor our CPU usage just from where we are. We are not going anywhere. And let's look at the charts that are starting from CPUs. So these are the ones that come with CPUs. So let's see the instruction. So the first question is, which chart shows the average CPU utilization across all nodes? So which chart tells us the average CPU utilization across all the nodes in the clusters? So you can also like go over all these ones to even see what this particular chart is showing. And this is what we are concerned with. The average CPU utilization across all nodes in the instance cluster. So the recommended threshold is 70% for instance with one cluster or multiple cluster and single cluster routing. 35% for instances with two clusters and multi-cluster routing. So these are just this is the chart that we are majorly concerned about, and this is what we are currently. You can see we are just a little bit above 20%, and that's good to go. So this is the name of the chart, CPU utilization. You can click on submit. So for the existing cluster, is the CPU utilization for the busiest node below the recommended limits of 90%? So the existing cluster that we are on, so our existing cluster is this one. Is it below the recommended maximum of 90%? So you can see the recommended marks, and what we are currently at is just 8.9%. So this has also even dropped to 7.75, depending on the depending on how the data flow job is reading the data at that particular moment. So that's regarding that, and we'll pick this. Yes, click on submit. So that's all for tax 2. It's just to monitor the disk and CPU usage, and we can see the different metrics that are going on there. So our first task should have been complete. Let's check our status here. So the status here is also complete. So for task 3, we want to configure node autoscaling. So what autoscaling typically means is that the Bigtable instance automatically scales depending on maybe the metrics that we have set at that particular time. So there's a CLI command to enable autoscaling, and that's what we'll be doing here. So let's enable this command. When you click on this command, and what this command typically does, it's just a CLI instruction for updating the configurations of a Google Cloud Bigtable cluster. So if you would break this command into pieces, the first part, Gcloud Bigtable clusters, update San Diego traffic sensor C1. So what this is just the main command for updating a Bigtable cluster configuration. And the clusters that we are concerned about here is this San Diego traffic sensors. So under the instance we are concerned about is San Diego. Here we are setting the minimum number of nodes for autoscaling to 1. So autoscaling typically adjusts the number of nodes in the cluster based on the workload. And we are also setting a maximum autoscaling nodes. So the maximum we are setting here is 3, and this just means that our cluster can dynamically scale up to a maximum number of 3 based on the workload at a particular time. And the last parameter we are passing here is autoscaling CPU target. So we are setting our target CPU utilization to 60%. So having a autoscaling CPU target of 60%, what's going to happen is that autoscaling will aim to keep our CPU utilization around this particular target figure, and it will automatically increase our node in line with this target. So for this one, since we have a autoscaling CPU target of 60, and we have a minimum number of nodes at 1 and maximum at 3, so it will automatically scale between 1 to 3 to have this 60% target. But if it gets to a place whereby we have to scale more than the autoscaling max of 3 that we've set, that means we have to do that manually, or we'd have to increase the limits of the autoscaling maximum nodes. So that's about that. So let's copy this command and run it on our cloud shell. And so before we do that, let me just show you something. I'm going to the overviews, and when I click on this is our cluster ID. You can see that this is the cluster ID that we passed in our autoscaling command. So if you take a look at this pencil icon, you would notice that this thing is set to manual allocation, and the current quantity of nodes that we have here is 1. So when I run this command, it's going to change the setup, and you see that we will now switch to an autoscaling setting, and we'll be able to change the amount of nodes, or be able to increase the allocation of the amount of nodes that we have on this cluster at the moment. So I'm going to drag this thing up and run the command I copied. So strike on enter. So let's wait for the command to get done. So, and it's now done. So the next thing we can do here is let's take on this pencil sign once again, and it has not yet populated here because it's not refreshed at this moment. So I'll try to refresh it. Let me just refresh here. Yes, let me reload the site. You don't necessarily have to actually reload through this format. You can just go to the overviews and initiate the refresh from the overview page. So this is more of like an extensive refresh. So yeah, so we are back at this cluster ID part. So when we click on this pencil icon now, you should see what I'm saying. So here now, before it was on manual allocation, and now it's now on auto scaling, and this is the minimum that we passed here, 1, maximum 3. Our target that we put here is 60%, and our storage utilization target here is 2.5, which is just like 50% of the current storage capacity. Yeah, so that's it. So what is the storage utilization target for this cluster is what we mentioned before. our storage utilization target is 50% because now we are in 2.5% of a 5 terabyte. We are setting a 2.5 TB from a 5 terabyte per node. Yeah, so we are good. So click on submit here and we are correct. So let's check our progress and see if we are in line with what this lab wants us to do. Yeah, so I suppose we are in line. So the next task is to configure replication. And while we are configuring replication, so what replication typically means is that say an instance has only one cluster. That means the durability and availability of that data is limited to that zone and where the cluster is located. So a disaster in that particular zone where your cluster is and something happened to your data in that particular part, so your data get lost if it's not replicated. But if you replicate in multiple zones or multiple regions, so your data can have improved durability, and there can be multiple separate copies of your data available in multiple time zones or region, and you can automatically fail over between different clusters if you want to. So let's configure replication. To configure replication, we'll go to our overview page, and under our instance, San Diego, we'll try to edit the instance and add another cluster. So go back here under the overview. This is our cluster ID. Let's try to edit the instance here. And after that, we would attempt to add a new cluster here. So the name of the cluster we want to use is San Diego Traffic Sensor C2, and it will be in US East 5. So the region that we are choosing is US East 5. I think we are fine with any zone. Yeah, this lab wants us to pick any available zone. So the auto scaling that we are using is the manual. Okay, let's do auto scaling. So this same thing that we were able to do using the command line, we could have done it with the console here and change our auto scaling settings. But the lab wants us to use 1.3, then a target of 60%. Yeah, as specified here. And after that, we can add. So let's add this. And so we've added, then we can now save this part. So that what we are about to do is just to create a new cluster in the instance that we have in our Bigtable instance. So now we have two clusters. If you go to our overview, you can just so these are the two clusters we have. The first one is San Diego Traffic Sensor C1, and the second one is San Diego Traffic Sensor C2. So you can see this is still like pretty much like creating, but it's fine. So the next thing we want to do is let's check our progress. Yeah, so it's still replicating. And for the next task is to back up and restore data in Bigtable. Would back up a particular snapshot or like a particular condition of that our data in Bigtable at a particular time. Would back it up, and you can easily restore that backup at that current time, at that current state of our data anytime we need it. So this is just typically useful when we want to restore the backup to a new table as needed. And so when we back up something, we can restore the data to a new table when we need it. So typically, just to make it clearer, replication is majorly intended to enable failover to a different region or zones. So let's say the current region that we have is currently out of service. We can easily fail over to a different region. So that's the importance of replication. Backups are intended to like help us recover data when there's an application level data corruption or operational error, such as an accidental table deletion. So when someone mistakenly deletes the table that you're using, you can easily go back to your backup and restore data from that backup. So let's create a backup of a particular table. So, and this backup that we're creating would create the backup, would specify the expiry date for that backup and thereabouts. So let's see. So here we have our backups. Let's see how we can create a backup from a table. So let's go to our tables. So from our tables option, we have two clusters here. This is the current condition. So let's click on this particular part, and you can create a backup from here, or you can just click on this one also to create a backup. So let's create a backup, and it's setting. So the name that we want to use for this our backup would be, let's choose this second cluster. So here, this is our table by the current condition. So this is the table that we want to make the backup on, and this current condition is under this cluster San Diego traffic sensor C1. This is the first cluster that we had on our instance. So let's name a backup ID for this, and the backup ID we'll be using here is current condition underscore 30. So let's copy it here, and we can have a default expiry date. So default it was 90 days, but I'll just pick 30 days. 30 days is fine, and I can attempt to create a backup for this particular table. This just means is that this backup is going to automatically get deleted after like 30 days. Yeah, so this is our data at the moment. So we can just cancel out of this. So when you cancel out of this, you'd see all the backups that we have here, and they are here. So we can also go to tables to explore all the tables that we have now. So let's refresh this. So it's still, you can see that it's still one. It's still one. So when we restore from our backup, you would now see that we would end up having two tables. So let's go back to our backup. So this is still our backup, and we can just attempt to restore. But let me follow the lab instruction. What's the next thing? Yes, so that's typically the next thing. Let's restore our backup. So if I attempt to restore this particular data, and so it wants me to select an instance to restore the data to. So which one should I select from the lab? Okay, so they want me to use this name as this. Yeah, so we are good. So let's still pick this instance. So it's actually even only one instance we have on this our Bigtable instance. So we only created one instance, San Diego. So but let's go to this name table. So the name that we are restoring will now be current condition 30 days underscore 30 underscore restored. That's the name that we are picking. Then we can click on restore, restoring our backup for us, and here we are. So that if I cancel out of this one, we would see the two available tables that we have now. So we have current condition, which is the table that we had before, and the new one is current underscore condition underscore 30 underscore restored, and that is still setting it up for us here. So now it's ready. Yeah, so there's a backup for this one already. You can see that it's just showing the latest backup. But for this new one that we restored, we can also create a backup for it also and go through the previous step that we've done. So let's check our progress. Our progress is complete. So the final thing we'll do for today is just to delete the backup. And to delete the backup, you can just navigate to the name of the backup and delete the backup. Now that we've restored our backup, you can easily delete the backup since we've already restored it. So, and don't forget that this backup is set to an expiry date of 30. So if you did not automatically restore, if you did not restore within that time, this backup is going to get lost. But since I've restored, I can just do a delete. So I can just then paste the backup ID of the table that the backup that I want to delete. So this is the backup ID, then I would click on delete. So this extra check is just to make sure that there is no accidental deletion of your backup at that particular time. Yeah, so our backup is deleted. We can just go back to our tables and see how we are doing. If you want to check the monitoring insight from one last time, you can also see, and you can see how it has changed before we end the lab. So we have it here. You can see the graphs. So it's going across different spikes, and everything is still very much optimal. So we are still far off the recommended maximum. We are still far off the recommended maximum here also. And this is the read latency. What else? So storage utilization. We are not actually consuming a whole lot of storage at the moment. And yeah, that's regarding that. So read request, just few read request. Yeah, I think we are actually good. We are actually good to go at the moment. and we can easily end this lab. So congratulations for staying with me till this moment. So you've completed key tasks to monitor and manage the health and the performance of your Bigtable instance. So which included reviewing the disks and CPU, which includes reviewing the disks and CPU utilization, enable node autoscaling and replication, and finally backing up and restoring your data. So if you enjoyed this lab, make sure you like it and comment your thoughts in the comment section. Let me know what you think about this lab and also share. That's all for this lab, and see you in our next lab. Bye for now.